Hello everyone, welcome to my YouTube channel. So here today we are going to be determining the domain. Now the domain is simply more like what x values can you use, in other words. So what x values can you use? So whatever x values that you can use, that means to say it is your domain. Now the condition is that you will have to use real numbers. So real numbers are all the possible numbers that you can think of. You can talk about the square root of 2, square root of 4, which is equal to 2. We have 1, we have 2, we have 0.5, we have negative 7.5. Any number that you can think of is a real number except imaginary numbers, such as the square root of negative 1, which gives you I, or the square root of negative 4, which gives you a 2I, like that. So we just want our domain to be numbers which we can put in a certain way, such that they are always going to give us a real number. They are not going to give us an imaginary number. So now let's try to find out what is the domain for the following. So to find the domain, we are only interested in what is in the square root. So if we have our first one, which is saying that h of x should be equal to x plus the square root of our 3x minus 4. So now the thing is that we are interested in what is in the square root only. To find the domain, what value can we use? Because already you can use any x value that you want as long as it's a real number. You can use 100, you can use 4000, but now there is a general rule to which one can you use. Because if you look at this, like for example, if you are looking at the domain of before we look at that one, you have the domain of the square root of x. Let's say we have our h of x is just equal to the square root of x. Now there are some x values that you cannot use for this equation. Like for example, you cannot say that my x should be equal to negative 1, because if I put negative 1 here, it will be my h of x should be equal to the square root of my negative 1, and the square root of negative 1 will give me I. And this I is imaginary, meaning to say negative 1 should not be part of the domain. The domain should give me whatever I put there, it should give me a real number, or rather a real number at the end of it all. So therefore, in order for you to determine the domain of any equation, what you're going to be doing is this. So where there is the square root of x, you're just going to get the x and say it should be greater than or equal to 0. In that case, that means to say whatever value is greater than or equal to 0, it will always give you a real number at the end. Like for example, the square root of 0 is equal to 0. 0 is already a real number. If you get the square root of 1, this is also equal to 1, which is also a real number. If you look at the square root, let's say the square root of 4, it is equal to 2, which is also a real number. Whether you use the square root of let's say 2, which is approximately 1.42, that is still a real number, or you can just leave it like this. Now the main thing is that a real number, as long as you use a number, it should give you a real number at the end. So therefore, all these values that I was using, x should be greater than 0, I have used them. I can use 0 greater than or equal to, meaning to say I can use 0. If I use 0, it will be equal to 0, which is a real number. All I want is to know whether as long as the value that I am getting is giving me a real number, then I'm okay. That's the domain. The domain just talks about, does it give you a real number? If it does, then you are okay. Now if you look at that type of an arrangement, it simply means to say each and every time you have something in the square root, Now you only do this if you have the root of an odd. Like for example, we have the square root, we have the fourth root, we have the 60th root, we have the 8th root. The list can continue like that. As long as you have square root, fourth root, 60th root, 8th root, and so on, as long as it's an even number here, it simply means to say you're just going to get what is inside. If it's 3x minus 4, then and say it should be greater than or equal to 0. If it's greater than or equal to 0, that means to say if your final result is 0, you can still evaluate your answer. If your final answer is 1 after finding out that, then you can still evaluate the answer. So now, with that said, let us now be able to solve the question. So let's say we have x plus the square root of 3x minus 4. So since this is the square root, to find the domain, we are going to say domain. We are going to get what is inside. Just the inside is important. We don't care about what is there. We are just going to say 3x minus 4 should be greater than or equal to 0. Then we take our 4 there. It will be our 3x should be greater than or equal to our 4. When the 4 goes that side, we divide by 3. We divide by 3. It will be our x is greater than or equal to 4 over our 3, like that. So if your x is greater than or equal to 4 over 3, that means to say your solution set should be equal to, we have the smallest value with included, we are going to use a square bracket. We have a 4 over 3, comma, all the values that are greater than 4 over 3 will go up to some positive infinite, like that. Then let's look at our next one. If you have such a situation, what do? You're going to find out what is the domain for this one. So you're going to set this greater than or equal to 0. You're going to say x should be greater than or equal to 0. And you're also going to set this other one also should be greater than or equal to 0. And say x minus 1 should be greater than or equal to 0. So this one already you are saying that x is greater than or equal to 0. And this one, you take the one the other side, it will be x is greater than or equal to positive 1, like that. So now, which one are you going to take? So you are going to look at which one can favor the solution. Now we are saying that it should be greater than or equal to 0. It means to say, let's try 0 if we put it in the original equation. Let's say k of 0 and say should be equal to the square root of, where there is x we put 0, then where there is plus the square root of 0 minus 1, like that. We are going to have the square root of 0 is 0 plus the square root of 0 minus 1 is negative 1. Now this already is imaginary. So that means to say the solution of saying that x should be greater than or equal to 0, meaning to say you're saying that 0 can be used, is false. But if you get this to say, let's say I get my 1, I put it there, it will be equal to, we have our k of 1 should be equal to, we know that our equation is the square root of x, where there is x we put 1, then we have plus the square root of our x minus 1, which is our 1 in this case minus 1, which will be equal to the square root of 1 is 1 plus 1 minus 1 is 0. So we have 1 plus 0. Now you see that as long as it's giving you an answer that is real, that means to say that is your solution. So therefore, we can be able to say that the value we had x is greater than or equal to 0, and we also had our x is greater than or equal to 1. So our solution that we are going to take is such that our x is greater than or equal to 1, because it is the one that is satisfying for both conditions. Now to do this, there is an approach using the number line. We have two numbers, 0, we also have a 1. For this one that is saying that, let's begin with x is greater than or equal to 1. That means to say we are beginning at this point. all the values that are greater than 1 are this side. That's the meaning of x is greater than or equal to 1. Then for this one, we are going to have our x is greater than or equal to 1. So greater than or equal to 1 means you are going to be going to your right like that. Then what this means is that already you see that they are both going the same direction. Now you are going to take where these meet, more like both of them meet. You are not going to take this because already they are not more like meeting the requirements for both of them. So therefore you are going to take the second one, which is your 1. So that's why we even took our x is equal to 1. So we took our x is greater than or equal to 1 for that reason. Now for our third one, we have our third one, which is saying that f of x should be equal to the fifth root of our x plus our 3. Now to answer this, let me first be able to just look at something simple. Let's say we have, as long as you have an odd number, it could be the cube root. Let's say you have the cube root of -8. You also have the cube root of +8. So the cube root of -8 is -2. The cube root of 8 is +2. If I multiply -2 times -2 times -2, negative times negative times negative times negative, it's positive, times negative, it will be negative. 2 times 2 is 4, times 2 is 8, so it is -8. If I multiply 2 times 2 times 2, it will give me +8. Now what does this tell me? It tells me that whatever value that you have in a cube root, fifth root, seventh root, as long as it's an odd number, it shall always work. Whether I put the cube root of a 0, whether I put the cube root of a -1, it will still give me an answer, which is my -1. Cube root of 0 is 0. So whatever value that you are going to use, it will always work under we are looking at the root of an odd number. So in that case, if we have the fifth root of what value are we provided with? X plus 3. So it does not matter what is inside. So the fifth root of x plus 3, so we are just going to say that. So the domain, we are going to just say for this one, or real numbers. As long as it's a real number, it will work, because whatever value you are going to put there is going to allow your equation. But for the square root, there were specific values that will not give you a real number. Now, if you to represent this one as in interval notation, you're going to just say negative infinity to positive infinity. That is the meaning of all real numbers. So if you have your k, x should be equal to the fourth root of our 2x plus our 3, like that. As long as you have an even number here, you are just going to get what is inside and say that it should be greater than or equal to 0. So you are going to say 2x plus our 3 should be greater than or equal to 0, like that, as long as you have the even number here. So we are going to say 3 goes the other side, it will be 2x greater than or equal to, the 3 comes here, negative for that matter when it crosses that sign, then over 2, then that means to say our x should be greater than or equal to -3/2. Now to write this in interval notation, we are going to say, since -3/2 should be included, we are going to use a square bracket and say -3/2. If you look at x, if x is greater than this, it means to say the highest value will be a positive infinite. If it is greater than this negative value, like that, it continues like that. To look at our v is saying that we have our f of x should be equal to x squared plus our square root of our x squared plus our 4x, then we have minus our 12 like that. Then we are told to say find the domain for this one. So we are just going to take whatever is in the square root. That's the only thing that we are interested in. So we are going to say our x squared plus our 4x minus our 12 should be greater than or equal to 0 like that. Then what we are going to do is solve the quadratic. So we have the product which is equal to AC, where the coefficients of this are our A, our B, and our C. So here in front we have A. So AC, it will be equal to 1 times negative 12, which is equal to negative 12 like that. Then the other thing is that we are going to have our sum. So we have negative 12. Our sum, which should be equal to B, should be equal to our B value is A, 4 like that. Then we have our factors. Our factors, which are two values, when we add them, they are going to give us a positive value. When we subtract them, or sorry, when we multiply them, they are going to give us a negative 12. So those values are 6 and negative 12, or negative 2, sorry. So we are going to have our x squared. So we have our x squared as our equation. Then when there is 4x, we are going to put 6, attach x. So we have 6x. Then we have minus our 2x. Then we have minus our 12 greater than or equal to 0. So factorizing this, so x is common. Then we have our x plus 6. Then we have minus our 2. Where there is x, we are going to put, so if we factorize 2, we are going to remain with x. Then where there is, since this is negative, it cancels with this, so we are going to have positive 6. Should be greater than or equal to 0 like that. Take the brackets and say x plus our 6. Then another bracket, it will be x minus 2 should be greater than or equal to 0. Then as long as it's a quadratic equation, what we are going to have is we are going to find the critical values. So the critical values are the zeros of the equation, which will be taking our x plus 6 to be equal to 0, or x minus 2 to be equal to 0 like that. Then this means to say we are going to have our 6 goes to the other side. We have our x is equal to negative 6, or our x is equal to positive 2 like that. So now drawing a number line, we are going to just be having 2 is greater than negative 6. So 2 here, then we have our negative 6. So drawing our number line, it means to say all the values that are this side, all the values of x could represent these values, they are less than negative 6, because as you are moving to your left, it means to say you are decreasing. So all the values that are this side are less than negative 6. Then here we have our x should be greater than 2. So all the values, in other words, that are this side are greater than 2. Then the other thing, it will be our negative. So here we have an interval. We have, let's say here we could have negative 5, negative 3, and so on. We have a 1. Now all these values, negative 5, negative 3, negative 2, they are such that they are greater than negative 6, but at the same time less than a 2, because the highest that you can go in between, just the middle part, is greater than negative 6 but less than a 2 like that. So after doing that, what we are going to do is let's come up with a table. So we have our factors. So we have our factors, which are the values that we factorized, in this case x plus 6 and x minus 2. So we have our x plus 6 and our x minus 2 like that. then we are just going to say our product like that. Then what we are going to end up with is, for our first interval, we are just going to copy. So our x is less than -6. The second interval is such that we have this one on the middle, 2. Then the last one is such that we have our x is greater than a 2, like that. Then we are going to ask ourselves, if x is less than -6, then it means to say x could be equal to -7. It could be -8. Then if x is in between -6 and 2, it could be any value, so long that as it is in between. So we have x is equal to 0. You can use 1, you can use you can even use -3 to say okay. If x is greater than 2, it means to say x can take a value such as 3, 5. For the sake of simplicity, we use small values. So if we put our -7 here, it will be, where there is x, we put -7 plus 6, which is equal to -1. So which is our negative, like that. Then when we have our x minus 2, we put -7. We are going to be having a -7 minus 2, like that. Where there is x, we are going to get a negative. So we are going to say negative, like that. Then negative times negative, that's our product. We are going to have our positive, like that. When we put 0 here, 0 plus 6, it will be a positive. 0 here, 0 minus 2, it will be a -2, so it will be negative for that matter. Then positive times negative will give us a negative. Then last but not the least, if we put a 3 here, it will be 3 plus 6, which is 9, which will be a positive. If we put 3 here, it will be 3 minus 2, which is a +1. So we put a positive at this point. Positive times positive, it will be a positive, like that. So now, to get which one, so we know that this is our product, and we also know to say our equation was saying that our x plus 6 and also our x minus 2 should be greater than or equal to 0, like that. So that means to say we are going to get the ones that are, if you multiply this one and this one to get your product, you should have a value that is greater than or equal to 0. So the value that is greater than or equal to 0 is 2 positive values, like that. So this one is greater than or equal to 0. So we are going to take this one. So either our x value that can form the domain should be x should be less than a -6. Now we are going to put this to show that because it's saying greater than or equal, so meaning to say even our answer, then you are going to say, or you are going to have your x, the other positive is coming from here, which is x should be greater than 2. So we are going to say x should be greater than 2, but since there is an equal sign, we are going to have that. So to write our domain in terms of set interval notation, if x is less than -6, so meaning to say the smallest x value is negative infinity to -6, then we say union 2. If x is we use a square bracket there. If x is equal to 2, greater than or equal to 2, it means to say the smallest value you can begin with there is a 2. So we are going to say 2. The highest value you can go is a positive infinite as your answer. Let's look at our last problem. So whether you have a rational, it is still, as long as you have the square root, fourth root, you are going to use the same thing. You're going to say x plus 1 over our x minus 1 should be greater than or equal to a 0, like that. So you're going to do from here, you're going to find your critical values. So the critical values are the zeros of the equation, meaning you equate your equation to 0. So you say x plus 1 is equal to 0. Or you are going to say x minus 1 is equal to 0. But remember, since this is a rational function, x in this case should not be equal to 1, because if you put 1 here it will be 1 minus 1, which is equal to 0, but we don't want a 0 at the denominator, though we are going to say x is equal to 1 as our critical value to just help us come up with an interval. So we are going to take the one the other side, it will be equal to -1, or we are going to have our x is equal to, when we take the one the other side, it will be +1, like that. So if this is the case, then what we are going to do is, let's come up with a table of values. So our number line should have our -1, which is smaller than 1. So same approach. So all the values that are this side, they are less than -1. Here we have all the values that are this side are also greater, we have all the x values here are greater than 1. Then here we are going to have an interval, which is a -1 less x less 1, like that. So that means to say this is what we are going to use. So we have x is less than -1. The other one is saying that we have a -1 less x, while x is less than 1. Then the last one is x is greater than 1, like that. So this is what we are going to have. Then what we are going to have when we do that, we are finding out that in this case, if x is less than -1, it means to say the value of x could be equal to a -2, any value that is less than -1. Then here in between -1 and 1, it will be x is equal to 0, and finally here it will be our x is equal to any number that is beyond 1. We can have a 2, 3, 4, it's okay. Then the factors are the ones that we used, which are our x plus 1 and our x minus 1. So it will be x plus 1 and x minus 1. Then when you divide, you're going to get a quotient, like that. So we are going to find that when we put our -2 here, it will be -2 plus 1, which will be a negative. If we put -2 here, it will be -2 minus 1, which is equal to -3. So negative times divide by negative, it will be a positive. When we get a 0, we put it here, it will be 0 plus 1, which is equal to a 1. When we put a 0 here, it will be 0 minus 1, which is a -1. So we are going to have a negative. Then when we positive divide by negative, it will be a negative, like that. When we get a 2, we put it here, it will be 2 plus 1, which is equal to 3. 3 is positive, like that. When we get a 2, we put it here, it will be 2 minus 1, which is positive as well. 2 minus 1 is +1. Then positive times positive, it will be a positive for that matter. So this means that the values that we are going to take are greater, because it's saying that remember, when we found that our x plus 1 over our x minus 1 should be greater than or equal to 0. So the sign that is greater than or equal to 0 should be a positive is greater. So you pick the positive. So we are going to have the equations that we are going to take are such that x is less than or equal to -1. So we are adding the less than or equal to -1 on this one, and say, or we have our x for this other one, which is our x is greater than 1. So our x is greater than 1. Now take note that we are just going to say our x value should be greater than 1. This is simply because we cannot have, remember what I said, that first x cannot be equal to 1, because if x is equal to 1, we are going to have 1 minus 1 on the denominator, which is 0. And if the denominator is 0, then the equation is undefined, like that. So therefore we are just going to say x is greater than 1, like that. So to write the interval notation, if x is less than or equal to that, it means to say the smallest will be a negative infinity to that value that you have been given. Then you're going to use a square bracket, then you say union. If x is greater than 1, it means to say the smallest you can have is a 1 with not included with this bracket. Then say should be the highest, if x is greater than 1, should be a positive infinite, like that. So this is how we go about that. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.